Hello, my name is Paul Cusick. I'm an engineer by education, and I work in research in just about every field that universities teach in. And one of the fields I research is in physics. And in this case, this talk is about the ether, which was thought not to exist by people like Albert Einstein. But it looks now that there is such a thing as ether, and I show how it's modeled as Teflon, polytetrafluoroethylene, PTFE for short. So there's a quote from Einstein from 1920. It was highly honorable of his logical conscience that Newton decided to create absolute space. He could just as well have called the absolute space rigid ether. He needed such a reality in order to give objective meaning to acceleration. So we'll show at the end of the paper how light travels through the medium of ether. So this paper was compiled from 12 smaller papers that I've written on the ether. They're all brought together under one paper under a journal by the name of NESSA, N-E-S-S-A, and the reference to that is at the end of this paper. So we continue to theorize that the universal matter, the ether, is closely modeled as Teflon, which is C2F4 equals 2 carbons and 4 fluorines. We consider how the mass of the periodic table is made up of 116 elements, how the force on a charged particle fits in with the electric field and mass, how the superforce, which is 8/3, is derived from magnetism equations, how the Reynolds number, its value of 0.402, is overcome by the universal forces, and how electronegativity and ionization energy fit in with Teflon. In short, we show that the ether is like Teflon in all parameters. So the Teflon is like a face-centered cube, and there's a slip plane in the face-centered cube, and we calculate the angles of that face-centered cube. So two important facts about the astrotheology theory, which is my theory on mathematical physics about the whole universe, not just the ether, but the whole universe, is that the universe exists where the force and the momentum are equal. So, of course, force equals ma, momentum equals mv, so that's saying that v equals a. Since acceleration is a derivative of velocity, and velocity is a derivative of distance, then s equals v equals a. That's a critical factor in astrotheology theory. So a number that popped up often when we use the golden mean parabola is that if we plug pi into the golden mean parabola, which is t squared minus t minus 1 equals the energy, or is usually 0. If we put pi into that equation, we get the energy equal to 57.29, which is 1 radian. So in this paper, we make use of these facts coupled with material engineering to see why these two values are important. And we begin with the slip plane with the face-centered cube. So there's a couple of free body diagrams of elements from mechanics, and we see that when a force of 8/3 is applied, that's determined to be the superforce. It's equal to 2.6666 repeating. And when the angle is 45 degrees, we wind up with the force pulling in each direction there in the right-hand diagram being equal to 8/3. So PTFE, polytetrafluoroethylene, Teflon, is a linear polymer. It is 8 mers per molecule, and that happens to be 248 grams per mole, which works out to 1/403. 403 is approximately the Reynolds number for the universe. Reynolds number is the inertial forces over the viscous forces, or MA over 1/2 rho V squared, where rho is the density. So we calculate when we plug in the values that we know for the density. The density of the ether is 4 over pi, which is 127.2. When we plug that into our equations I just mentioned, we get mass equal to 1 over c squared. So that's saying the energy is equal to 1, because mc squared is equal to energy. So 1 over c, if mass is equal to 1 over c squared, the energy is 1. So there's a picture of the triclinic crystal. It's the most basic of crystals, basic crystal shapes. And we've used the parameters there of the whole physical universe, which is 1 by 8 by 22, or 3 light years by 24 light years by 66 light years. And the volume of the crystal is 76.6%. And we get our periodic, the period equal to 252 from the volume divided by the speed of light. So the sum there on the right hand side, 201.5 equals y, is the dampened cosine energy. And there's what from astrotheology, there's what's called the universal vector, which is 12.82. So we're dealing with the triclinic crystal. So there's the percent crystallization and percent amorphous. The crystallization is 76.6%. The so-called ether, as Teflon, is of course a fluorocarbon. We determined that ether is MERS of 8 parts long in a linear model. As per the picture there, the carbon backbone and the fluorines off the carbons. In this brief talk, we provide some more calculations to show that previously calculated crystallization percentage is related to base E, 2.71828. We begin with the molecular mass. We see these calculations indicate that the ether is Teflon. So there's on the right hand side is a famous diagram from astrotheology. It's the time versus the energy, and we have the mass is plotted as the ln of t, which crosses the x-axis or the t-axis at 1, and the line coming down there is the exponential to the power minus t, so it's decreasing. So mass begins in the universe when t equals 1, and it runs all the way until t equals pi, and then it cycles back again. So it's a cycle that keeps running through from 1 to pi for the mass. So some of the characteristics we see there of Teflon has the same density as concrete. The density of concrete divided by root 3. Root 3 is what's called the eigenvector of the time, is equal to 127 for the ether. And 1 atom of C2F4 is 88 grams per mole, which is 60 per atom. And if we plug that into our Reynolds number formula, we get the 23.61, which is the ln of pi. So that brings us to our energy time diagram there on the right. So we use basic physics. Very useful information in basic physics can be used at the highest levels. And here we have a block on a plane, which you encounter in first year university physics, or maybe even in high school now. And there's an important number, which is it's Young's modulus for the universe, which I call Q's, CUZ, but it's actually pi minus E, which is 0.4233. And we see there it's calculated in the equation. 1 over root 2 is the acceleration, is where sine and cosine are equal. It's the sine of 45 degrees is equal to the cosine of 45 degrees is equal to 1 over root 2 for your velocity and acceleration. So here we're using acceleration times the mass, where we just showed was 60.4242, which is pretty close to pi minus e, which is q's, if you want to have a label for it. The superforce overcomes the forces of friction. Note that Teflon has the third lowest coefficient of friction of all known materials. It's an important point, and it may be why the material, the ether material, is actually a Teflon, is because of the fact that the coefficient of friction is so low. So here we have the common diagram of the stress versus the strain, which we see in structural and civil engineering, and the slope of that linear portion is the Q's, 0.4233. We don't worry about the deformation or the rupture, just the linear portion. So the coefficient of friction is ranged between 0.05 and 0.1, which is noted as mu. The bulk resistance is 10 to the 18th, and density is 2,200 kilograms per cubic meter. That's lightweight concrete. Dielectric strength is 60 millivolts per meter, which is alpha, and the magnetism is 10.28 times 10 to the 6th. So now, using established formulas from the physics of electricity, we will show that the ellipsoid universe, 1 by 8 by 22, or in light years 3 by 24 by 66, can be modeled as a giant capacitor with the characteristics of Teflon. We calculate the mass, gap, forces, power, and capacitance. We see that the field electricity provides basic formulas that can be used to model the ellipsoid universe. So there's your circuit on the right hand side with a resistor of 0.4233, again Q's, with your capacitor with the capacitance of 1 over pi. The human mind has a frequency of 1 over pi, and so the human mind evolved to match the capacitance of the universe. And then we have an inductor, which has a value of 2 henries and a voltage of 105.2 volts. These are all characteristics from astrotheology that I'm not going to calculate here, just to show that what they are in the circuit. And we see on the left hand side there, we see where the capacitance is 1 over pi, and 1 cycle, of course, is, as I said before, on the energy time diagram, the ln of pi. And we calculate the mass, 117.36. There's actually 116 elements in the periodic table of the elements, and there's 2 that are unstable, 117 and 118. We see that number crop up all the time in astrotheology. So the permeability of free space is equal to 4 pi, which is equal to 1.2566. That's approximately equal to the minimum energy of the golden mean parabola. So if we take the golden mean parabola, t squared minus t minus 1 equals 0, or equals to e, and we take the derivative of it, it's 2t minus 1, and we find the minimum energy is minus 1.25, or minus 5 fourths, which occurs when t is equal to a half. A half squared minus a half minus 1. And we have the force of friction is mu n, so if we take the 125.66 newtons times the cosine of 60 degrees, 60 degrees occurs as often as 45 degrees does in astrotheology, and for reasons I won't go into here. And so we have 6.28, which is 2 pi newtons. 2 pi times Q's is equal to the superforce, 2.666 which is 8/3. So the superforce overcomes the force of friction. As I said, note that Teflon is the third lowest coefficient of friction of all known materials. The ether shows a likeness to Teflon for some parameters. So there's the mass gap and the magnetic energy density from basic formulas. Mass gap's around 150, and the magnetic energy density is the ln of rho, which is the ln of the density, which is the 127.2, which is 4/pi. So here we're about halfway through the talk, and we come up to, from chemistry and material science, we have Maxwell's construction and van der Waals equation. Known the critical temperature for the universal ether is T equals 300 Kelvin, which is about 30 degrees Celsius, and that the critical pressure is derived from the superforce. We can solve the van der Waals equation and this Maxwell construction for the universal ether. As more of these types of equations are solved, we hone in on material known historically as the ether. Please pardon the spelling mistake. So we have our formula there for critical temperature, and we have the ratio of the internal pressure coefficient over the internal volume is 57.29, which of course is 1 radian. And the time is, from Maxwell's theology, we know as the kinetic energy, which is 1/2 mv squared, or 1/2 rho v squared. And it also comes out to 1 radian. So there's the calculation for the critical pressure, which comes out to be 1/c squared. And our period shows up in there, 252. It's about 251.8 is the basic period of the universe. As I said, all these basic facts of physics can be applied at the most macro scale. There's van der Waals equation showing the density is 4/pi. And here is the helical shape for the polytetrafluoroethylene molecule. So we use some of the values we calculated in the previous slides. And space is equal to 4/3 there, which is 1.333. And the 15 carbons in the backbone, you end up with the superforce. And end up with the density there, 126.2, which is approximately equal to the density. The crystallinity is 76.6%, and the moment is 1565. So we consider some calculations from established equations taken from polymer physics to see where the PTFE ends up. We have found that some results are recognizable vis-a-vis AT math, or astrotheology math. The equations used in the following calculations come from reference one. The references are listed at the end of the paper, at the end of this talk. So there's a formula for entropy calculations. 225 is the result from that entropy calculation. And then 329, and we end up with L equal to 2.988, which is approximately equal to the speed of light, which is 2.9979. So we see that the constants from astrotheology math are evident when the ether is considered as a polymer. And there's your trans and gauche on the right hand side. And we consider the ether as the polymer PTF here, as Teflon in the previous papers on ether. There's actually 13 papers altogether, I think, at least on the ether that I've written, that are published in different journals. One of them all comes in one paper by NASA, a new journal, They published all 10 papers. It's about 45 pages long on the ether. So the ether is the mass and ancient mathematical physics. The universe is made up of two masses that have the densities of steel and concrete. The density of concrete is the same as the ether, and regular steel would be the visible mass. We explored the ancient Indian mathematician Brahmagupta, who knew that energy, mass, time, space, force, and the golden mean parabola, and the zero vector. The ancients knew more mathematical physics than we thought they knew until now. Brahmagupta lived around 600 AD. But some of this astrotheology goes back to the Babylonians and the Egyptians, so it goes back perhaps thousands of years. So our final topic here is the how light travels through a medium. It actually has a medium, which is the ether, which is contrary to what physicists believe for the last 115 years. So we consider how light or electromagnetic radiation travels through the ether. The ether was previously established as Teflon. It has a mass of 4/pi and a coefficient of friction of 0.4. Light travels in the form of waves. We use these characteristics to calculate how light travels through the ether. Consider the following figure and connected equations. So we see familiar constants drop out, assuming that light travels through ether as a regular wave. A critical point for astrotheology is that the function is equal to the negative of the derivative. So the function is the golden mean parabola t squared minus t minus 1, and the derivative is 2t minus 1. So if we solve that for t, we get 3. If we plug t in as 3, we get the energy equal to 5. That's what's listed there on the slide. So we have the force of friction, and we end up all the way down here at the bottom, and you can see it, that SE is the soul energy. It comes back to the terminology I used at the beginning of astrotheology, was to show that the soul was a true reality for us. And when SE equals SE prime, it's the same thing as saying that Y equals Y prime. I corrected that recently. It's actually Y equals minus Y prime, or you put the minus sign on the other side. But it's Y, or minus Y, is equal to Y prime. And there is Planck's equation. We end up with the superforce, and we end up with the speed of light. And that's the top equation there is the cross product of energy and time, which is space. And we end up with 1. So the momentum is equal to mv, is the cosine wave. Force is equal to the sine wave. So we end up with G equals 6.67, gravitational constant. And when we plug that into our Newton's equation on gravity, we end up 4.444, which is related to orbs. But I won't get into that here. I've written papers on the orbs if you want to look them up. And as we're coming to the end here, we see that we continue with the thesis, ether is Teflon. We examine how light reflects off a crystal plane formed by the fluorocarbon polytetrafluoroethylene. We see that the calculations provide parameters that are critical in the general theory of astrotheology. We also see that the ether is well modeled by PTFE. We begin with the linear density and continue with light diffraction. We see these calculations that the ether is well modeled by PTFE. It's a lot easier to say than polytetrafluoroethylene, which is probably why they abbreviated it. So we have the displacement in the electric field. And an interesting diagram there on the right hand side where the light rays are reflected off the various layers of the crystal. There's an important triangle that comes up all the time in astrotheology. It's a 30-60-90 triangle, or the 1-2-√3 triangle, and it's paramount importance. So there's Bragg's law, and the light integer and the frequency. We have force on a charged particle, 1.6528, and we end up with the mass of the periodic table, 116.52. This is the last stable element. Periodic table, ultra heavy elements in the universal Reynolds number. We end up with the Reynolds number of 402. There's the dampened cosine energy. Y is equal to e to the minus t cos theta. And we end up with the mass of Teflon is 60. And that is the paper that I promised I'd show you about in the NASA Journal of Physics on Teflon ether by me in 2021. And there's my email address, stmichael@hotmail.com, st-michael@hotmail.com. There's other references. So that's it. That's the talk, and I hope you've enjoyed it. I enjoyed preparing it. Thank you very much.